Hello. Alright, so the purpose of this video is to basically describe what the discriminant of the quadratic formula does. Okay, so let's go ahead and consider an example that we have done already in the past. So let's say we're given this quadratic equation. We want to solve something like x squared minus 2x minus 48 equals 0. If we go ahead and identify a, b, and c, and then we go ahead and solve for x, what we're going to get is we're going to get two possible solutions. And the reason why is, as you can see here, so the value under this square root is positive. So that's what I put here. The value under the square root is positive. Anytime you have a positive square root, in other words, anything that's greater than 0, you're going to have something that gives two real solutions, as you can see right here. So we have two real solutions. So in other words, when the value of b squared minus 4ac, so that value under the square root is going to be greater than 0, we're going to have two real solutions. And those two real solutions just so happen for this particular example would be 8 and negative 6. Okay, that's one case. Scrolling down, let's consider this case. Okay, so if I gave you this quadratic equation, same idea, identify a, b, c. If you were to solve for x, as you can see here, the value under this square root, though, is going to be 0. Okay, and the square root that's equal to 0 will always give one solution. And that solution for this particular example would be x equals 3. Now, the reason why this happens is because remember what I mentioned before. So anytime you take the square root of 0, well, the square root of 0 is 0. Whether we add or subtract 0, it doesn't matter. We're going to get the same thing anyway. So that's why when you have a square root that's equal to 0, you're going to get one real solution. So in other words, if this value under the square root, the value under the square root here, b squared minus 4ac, if that is equal to 0, we're going to have one real solution, which would be right there for this particular example. Okay, scrolling down. And now this is something that we just went over not too long ago. Okay, so we have x squared minus 4x equals plus 29 equals 0. And then again, identify a, b, and c, solve for x. And by doing so, we get two imaginary solutions. So as you can see here, the reason why is because the value under this square root, this part here, the value under the square root is negative. And a negative square root over here, so we get square root of negative 100, a negative square root will always give two imaginary solutions. And these are two imaginary solutions that you see here. So in other words, when the value of b squared minus 4ac, this is b squared minus 4ac, if the value in the square root is going to be less than 0, we have two imaginary solutions. And like I mentioned before, two imaginary solutions is the same thing as having no real solutions. Okay, let me just go ahead and show you in Desmos what this looks like. Okay, so if I were to graph that equation for you, so I'm going to graph the left-hand side. So left-hand side says y equals x squared minus 4x plus 29. And if I graph the right-hand side of the equation, and that's just y equals 0. So as you can see here, if I zoom out, right? So this implies if we were to graph it, we don't have any solutions. We have no real solutions. But if the way that we can express imaginary solutions, we have to change I equals the square root of negative 1 in our problems, and we can actually express this problem as two imaginary solutions. So again, two imaginary solutions is the same thing as having no real solutions. Okay, now let's come down here. Now this last part that I see here. So in the quadratic formula, basically the expression b squared minus 4ac is called the discriminant, and that's what I mentioned earlier at the beginning of the video if you didn't hear it. So that value b squared minus 4ac is called the discriminant, and its value determines whether the solutions of the quadratic equation are real or non-real. So in other words, non-real is the same thing as imaginary. So as a recap, if the value under the square root is greater than 0, or it's positive, you're going to have two real solutions. If the value under the square root is equal to 0, you have one real solution. And if the value under the square root is less than 0, then you're going to have two imaginary solutions. Or in other words, non-real solutions. Okay? Let's try to do an example just to make this a little bit more clear. Okay? So, let's say I gave you something like this. So, let's say I was given x squared minus 2x minus 48 equals 0. And I asked you to identify how many solutions do we have? Okay, how many solutions do we have? So again, what we want to do is we identify A, B, and C. So A is 1, B is -2, and C is -48. Now, just as a recap, the discriminant basically tells us whether we're going to have 2 real solutions, 1 real solution, or 2 imaginary solutions. The discriminant is calculated by that value under the square root. So that's b squared minus 4ac. So let's go ahead and calculate b squared minus 4ac. So we have -2 squared, because b is -2, and then minus 4 times, and then a is 1, c is -48. So if we go ahead and calculate the discriminant, maybe I'll just make sure to write this this part here, so you can see it. I'll put that on the side here. So this is b squared minus 4ac. Okay, so -2 squared, so -2 times -2 is going to be +4, and then 2 negatives here become positive, and we have 4 times 1 is going to be 4, and then we have 48 times 4. So 48 times 4 looks like it's going to be 192. So yeah, so we have 192 here, and 4 plus 192 is going to be 196. So now the question is this greater than 0? Is this equal to 0? Or is it less than 0? Okay, so what I see is, well, 196 is a positive number. That is greater than 0. So based on the rule for the discriminant, right? So if b squared minus 4ac is greater than 0, so in other words, we got 196 is greater than 0, we have 2 real solutions. 2 real solutions. Let's check that. Let's see if that is what we got earlier. Do you see this problem here? X squared minus 2x minus 48. So yeah, based on that little rule, we have 2 real solutions, and those 2 real solutions are right there. So this, if you're wondering, is a way that you can figure out how many solutions that you have without actually calculating or actually trying to solve for x, trying to use the quadratic formula. This is a little shortcut that you can use if I just asked you how many solutions do you have. Of course, what you could do is you could just calculate it if you want, just brute force that thing, and then just figure out you are going to get 2 real solutions. But yeah, so that's why that's the purpose of the discriminant. It basically tells you how many solutions you have without actually solving the problem using the quadratic formula. Okay, I'm going to show you a few more problems. I'm going to stop the video here. I'm going to continue really soon. Okay, bye. Hello. All right, so I'm going to show you 2 more problems. Okay, so let's say we're given this. So given 3x squared minus 18x plus 27 equals 0, how many solutions do we have? Okay, so again, we're going to use that idea of the discriminant. Okay, the discriminant again is basically the value under the square root, and that's b squared minus 4ac. So that's all we have to do. We need to just calculate that value. See if it's greater than 0, equal to 0, or less than 0. What I see, if I read this off, a is 3, b is -18, and c is 27. Okay, so what I see what we can do is if we were to calculate that discriminant, so, oh, that's a funny looking b, b squared minus 4ac, okay, and then we can go ahead and plug some of these things in. So we have -18 squared minus 4 times 3 times 27. If I do that real fast, so -18 squared, that's going to be just, well, that's going to be 8, just if the 2 negatives are going to cancel out. So 18 times 18 is going to be 324. Then we have 4 times 3 is going to be 12. 12 times 27, look something like this. We add it, so it's going to be 324. Okay, so we have 324 minus 324, and that's going to equal 0. So now, the question now becomes, well, is 0 greater than 0? Is it equal to 0? Or is it less than 0? Okay, well, what I see here, well, 0 is obviously the same thing as 0, right? So 0 equals 0. And the rule says that, well, if b squared minus 4ac equals 0, in this case, we have 0 equals 0, right? So we have one real solution. One real solution. Let's check that. As you can see here, this is the exact same problem that I put earlier. And the discriminant is 0. So since the discriminant is 0, we have one real solution. So again, what I mentioned was this, if I just ask you how many solutions you have, this is just a little shortcut. Of course, what you could do, you could brute force this thing, and you could go ahead and use quadratic formula, prove it for yourself. But if I'm just asking you for the number of solutions, this is just a very quick way that you can tell me how many solutions you have without actually applying the quadratic formula. Okay, I'm going to show you one more example. Okay, so I'm going to go ahead and just erase some of the things I see here. So erasing this. I'll leave that discriminant there. I was going to use that anyway. Okay, so all I'm going to do is I'm going to change the problem. So let's say I give you something like this. So let's say I am giving you something like x squared minus 4x plus 29 equals 0. Okay, and how many solutions do we have? Okay, so discriminant, again, we're going to use this, b squared minus 4ac, right? So what I see here, we identify a, we identify b, and we identify c. So I see a is 1, b is negative 4, c is 29. Next, what I see what we can do is we can go ahead and calculate b squared minus 4ac. So b squared minus 4ac, and then that equals, so what we have is we have negative 4 squared minus 4 times a times c. So we have negative 4 times negative 4, it's going to be 16. We're going to subtract. 4 times 1 is going to be 4. Then we need to do 29 times 4. 29 times 4, carry the 3, so 116. So what we have here is this is going to be 116. So 16 minus 116 is going to be negative 100. Now we got to do a little comparison. Is negative 100 greater than 0? Is it equal to 0? Or is it less than 0? Okay? Of course, what I see here is we have a negative number. Since we have a negative number, well, that means b squared minus 4ac is going to be less than 0, right? So we have negative 100, which is less than 0, right? So, which makes sense in this context. So, because this value is less than 0, we have two imaginary, I cannot spell. We have two imaginary, still can't spell, solutions. Two imaginary solutions. Let's check that to see if that's what we got here. Yep, this was like what we got. Pretty cool. Yeah. So, of course, this is the work for it, but you could actually do this without much work. I mean, you could do it with without showing actually solving the quadratic formula, using the quadratic formula. Right. Let's do one more. Let's do one more just for fun, since we have some time. Okay, so let's say I give you something like x squared minus 5x plus 6 equals 0. Okay? How many solutions? So same question. So what I do here is we identify a, b, and c. But like C, A is 1, B is -5, and C is 6. Okay? And then what we can do is we can go ahead and try this out. Calculate the discriminant. Discriminant is B squared minus 4AC. So all we're doing is we're just plugging in what we have. -5 squared minus 4 times 1 times 6. So -5 squared is going to be 25. Minus 4 times 1 is going to be 4. 4 times 6 is going to be 24. 25 minus 24 is going to be 1. Now, question becomes, is 1 greater than 0? Is 1 equal to 0? Or is 1 less than 0? Well, obviously, 1 is greater than 0. So, if we calculate b squared minus 4ac, of course, it's going to be greater than 0. We have calculated it to be 1. It is greater than 0. So, we have 2 real solutions. Okay? So, something like this. Now, of course, I leave it up to you as an exercise. Go ahead and use quadratic formula. See if you actually can get 2 real solutions. But again, what I mentioned is this is a little shortcut that you can use if I were to just ask you how many solutions you have without actually applying the quadratic formula. Okay? Please let me know if you have any questions on this. That's all I have for this topic. Okay, bye.